Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
I'm busy doing some video tutorials on some of the comments that I've received over the last 3, 4, 5 weeks. Some of them I just haven't had time to get to because I was busy with some other commitments. So I promise those friends, colleagues, that I will attend to their comments. And so this is what I'm busy at the moment. So this 166 was particular for a person that wanted to do snow cover density or volume for a artificial glacier in a specific region. So that's what I did 166. Before I continue, we have 498. Please, can we make it 500 by the weekend? It will give me a reason to go and have a nice ice cold beer. Wouldn't that be nice if you force me to go and have a nice drink, ice cold beer? I won't blame you. I promise I won't blame you. I will celebrate you in your absence. So please, let's get those numbers up. Let's get those numbers up. As Schwarzenegger or whoever said, go ahead, make my day. It's weekend. It's almost weekend. Time for a nice cold beer. So let's go. Let's get those numbers up. So please. Okay, so I also received a comment from a person that spoke about underground water. And I think the comment was something to, can we identify underground water? Can we measure it, etc., etc. So something that I haven't done before. So let's give it a try. So the first thing obviously is to go to our trusted Earth engine, go to data sets, and this time I'm going to look at browse by tags. Okay, you can search for underground water, or I'm just going to go to browse by tags. And then within browse by tags, I'm going to go to water, W. Underground, let's just see if there's something under underground. Where's you? MNOP. Oh, and now where's my alphabet? Talking about beer now, I'm totally off my alphabet. MNPQ, it's UV. Yeah, so there's U. Underground, nope. I don't know what un means. Let's have a look and see what un means. Oh, this is unit layers. Okay, so that's not much. So we're going to go to water. And you'll see if we have water, we have water mask, watershed. So there's a couple of tags that relates to water. So within water, let's go for this one. I would assume water mask and watershed would also be included in the main tag, which is water. So if you press on water, then they said what's 78. So here we go. There's a whole lot of these. So now, unfortunately, it's a bit of a painstaking exercise to run through each of these ones to go and have a look and see which of them may contain underground water or images related to water. Okay, so here's something here, global surface water mapping. Dataset contains maps of location and temporal distribution of surface waters. Okay, so this is surface water and provides statistics on the extent and change of those water surfaces. So that may be interesting. There's another one, surface water, but these are all up to 2021, but it's good for historical context. There's 1984 to 2021. They roughly, okay, so depreciated, we're not going to work on that. There's version 1.4, and this is metadata, so we're going to work with this one. So there's potentially something that we can work with. So we can have a look and see what that means. Water recurrence, temporal, it's similar, JRC version 1.4, JRC version 1.4. Here's the grace, and this is, yeah, grace monthly mass. We can go through this daily surface weather and climatological summaries. Um, daily weather, so that might be something. So, but you get the idea. We're going to run through them one by one by one by one until we find or those data sets that may be of use of us for us. Okay, and I've done this exercise. You can see there's what they said 78 of them. So that's unfortunately, if you're not sure, you haven't worked with one already, you're not exactly sure which ones to use. This is the way you do it. You go bias by tags and you just go to the necessary tags. You just scroll down each of these data sets until you find the data sets that you are interested in. So in my case, I found that JRC ones. I found the Metro, and I'm going to go for these ones. I found another JRC, which is monthly history, and then I also have by hour this one here, and also yeah. So I think there's five that I found. There's 5 or 6 that I found. There's another one here, and so I think there's 6 of them. So let's have a look at them. Let's go through them. So this is the first one that I've identified. So let's have a look at it. So I'm going to copy it. And then here I'm going to go into search and I'm going to paste that in there. And it should give me the option to go to its landing page. And let's have a look and see. So this is the one from 1984 till 2022 January, well, end of 2021. Global surface water mapping. And if we look at this, it says here, so it identifies areas or locations within your region of interest that had that, well, it takes your whole region of interest and it maps those places that had a frequency of water presence. Okay, so it means that area potentially has water, that doesn't have water, etc. etc. And there's a couple of other things that's interesting. The number of months where water is present, that's also quite fascinating. That it would be giving us that number, and I think that's quite a useful number to work with. So this one yields quite a lot of interesting results, which I think is good to use. So that's number one. So let's have a look and see what that looks like. And there's the occurrence, and so this is it. It's a single image. Okay, so it's not an image collection, so we don't have to reduce it. All we have to do is clip it for our region of interest. We have our minimum and maximum, and where do we get that? We go to occurrence, there's the minimum and maximum numbers. You see it's 30 square meters resolution, so this is very, very high resolution, which is very, very good. So that's our minimum max, our band that we select, and our color visualization parameters, and we just map in add it. Okay, so this is how it looks like. So let's make it a bit bigger. I'm just going to take my region of interest out, and basically, yeah, it identifies within my region of interest locations. Well, let me put this on again. So you'll see most of it has nothing. So it looks like there's nothing. But remember, that is basically saying that these locations don't, the occurrence of water is very low. The percentage of time that these areas have standing water is very, very low. And that's why there's nothing. So it will only display locations which have a frequency of water, at least on a monthly basis. So at least it should have a location where there's standing water for a month or longer. Okay, so this is why. And you'll see there's not a lot of locations. There's some locations around here, but you can see it is around these river systems. So you'll see the numbers are here. Okay, so it only identifies locations, as I said, if you look at the bands that has water frequency. So areas that have no frequency would be a 0, and therefore, if you look at it, 0 would be no color. There would be no color for that. Okay, so if we drill down, let's go and have a look and see. This is a river system, so obviously that should be. So if we have a look at it, you'll see there's some. So it focus on the river system. You'll see there. So it identifies these river systems. and it will map these river systems and other places that had water. You'll see that there's some locations that you see there, it will look, it will highlight those areas. Okay, so this is basically just with sort of dams, rivers, wetlands, etc. I said the nice thing about it, if we click on it, let's click on that, it will give you the occurrence is 98%, so 98% of the time it has water. And seasonality is 12 months. So 98, well, 12 months is exactly the same thing. Um, and there's the changes. So you'll just have to go through these ones to have a look and see what these numbers look like, or what the interpretation of these numbers. But the important part is the occurrence. 98% of the time it has water. It has water for all 12 months of the year. And that's what the seasonality is all about. Okay, so if I click there, for example, this area, you see they're all masked. In that, there's no water there. If we go there, let's click on that one there. It's 70%, and that just changes. So that's less water now than it used. And it's 6 months, which is typically the rain period. Reoccurrence 97%. Okay, so this is what this data set displays. So rivers, dams, and the like, wetlands. It will give it will identify water bodies, and it will give some statistics around those water bodies. Now, obviously, you can play around with the water, with the color schemes. That's up to you. Okay, so what's the next one? The next one is this called. Let's go and copy that one. We're going to copy it, and we're going to go to the data sets. And we're going to do the same thing here. We're going to search for it. Remember, I'm just still working on that comment. So although this particular one that we just did says nothing about water, underground water, it does give us some indication of water bodies. So it's not to the question or the comment directly. So let's have a look at the next one. Just going to move it here. So this is hydrography data sets 1987 to 17. So this gives you also some information around, you see, not too bad spatial resolution. It gives you on the elevation. It gives you the flow direction of the local drainage direction of these water bodies, east, southeast, which I think is interesting. The width, of the channel width, etc., etc. So this basically gives you further information. So let's have a look. Okay, so again, it's an image. It's not an image collection, so we don't have to reduce it. That's the code. We clip it. That's the band that we select is occurrence, which is sorry, it's this width. So let's have a look and see how that looks. With visualization of the river channel width. So this specifically focus on flowing water. So it will give you what's the width of your river. Okay, so let's see how that looks. And that's the width. Okay, so let's make it a bit bigger. So it overlays with the previous one, with the occurrence. You'll see it overlays with that one, but it gives you an indication of the width of the river. So if I click on this one here, let's say on this blue here, it will say that the elevation is 1 meter above sea level, so that's quite low. Direction is 64. So let's have a look at direction 64. It's north. So its drainage direction is north. So that means it's going this way, which is because this is north. So that makes sense. The width is 422. Is it meters? 422 up width. I would assume is meters. It doesn't. Yeah, it doesn't really say, but I would assume it's meters. Because that's, I think, can't be millimeters because that's very small. So this must be meters, can't be kilometers, that's too big. So this is meters. UPA, what does UPA mean? What does UPA? upstream drainage area, flow accumulation area. This is most probably where it receives its water from or something to that effect. I'm not too exactly sure what these numbers mean. One will have to spend a bit of more time to study them, search for them, do a bit of research on them, etc. etc. So it gives you indication of width. So there, which we had is for, so blue would be um, to the maximum end of the width, meaning increased width, quite large width, where the reddish colors are not much. And so it will give you a size of the dams as well, the width of the dam. So that width of that dam is 410. What's that other difference between the width? River channel width at the channel center lines. So it's just semantics, really the difference. So not too much. Okay, so that's that particular. Again, it identifies river systems or water bodies, and it gives you some statistics around those water bodies or water systems. Now, it unfortunately doesn't tell you how that has changed over time. It just gives you a singular image. Nonetheless, uh, I'm not sure whether we could. No, you won't be able to put a date in there. Okay. Uh, Not sure. Maybe you can. I don't know. Because here is also a singular image, but we can put a date in there. You can see we've added a date in there. So I'm not sure if we just forward slash and also put a date in there. We'll see now later if we can do that. Because although it's a single image, it may have the option to put in date. So we don't filter for date like a normal image collection. We just basically select that single image via that date. And this is what we've done here, for example, in this image. So let's go and have a look and see what this one is. Let's go and have a look and see what this one is. Copy, and we're going to go here, go data set. And I want to get to the main thing, but I think you get the idea. What we're doing here is just go through these data sets systematically. The results. So basically I need to, okay, it's giving me an idea. I need to just take out these dates. Here we go. And now that we've got the data set, now this is an interesting one because remember, like, as I said, it says it's an image collection, né? An image. So it's a single image, but it has a date format here at the back. And so this is quite interesting. It's the first time I've seen this. I haven't seen this before. Is that this is actually the date of that single image. So I can change this date. For example, I've in mind have it at 08. So I can change it. Sorry, let me just move it closer. I can change this date for this. So this is a date for that image. But if I change the date, then it's still just the image, which I found it's interesting. So I can change this. So this is a date. That's what I'm saying. I wonder if I can do the same here with these images. Now I'm wondering if you can do with other images, which is a single image by nature, but as you look at it, it gives you a range of time, but it doesn't allow you to do um, a selection of time here, like we normally do. So this is something interesting, but nonetheless. So let's have a look. So we just clip it. We give it. We give it a date. As I said, this is the first time I've dealt with this. This is interesting. You clip it, and the band is water. Let's have a look and see what the water is. Water detection for the month. So it basically indicates for that month. Okay. So that will indicate 0, I think, is nothing. Well, 2 is there's definitely water. So minimum is 0, and so it can have a value of 0, 1, or 2. So let's have a look what that looks like. Water. So let's have a look and see what that looks like. And there's our green. Our red is 0, which I would assume would be no water or water. Blue is water. You can see that. Let's click on that. that will give you water is 2. If we go red, that gives you water would be 0. Water is 0. So that's for that month. So interesting if we can change this. So if we change this, we're going to do that maybe a bit later. So that's another one, but again, it only detects water. It just tells you whether there was water or not for that particular month. Then we have this one, and this is, I think, where we start getting to the more interesting. So up to this, it's basically just identification of water, some statistics of water bodies, flows, width, etc., etc. So, but it doesn't really address the issue of um, underground water. Uh, so that's basically just surface water that we've now talking about, but it doesn't talk about um, underground water, which is the common. But I thought let's just talk about different data sets in any way so that we get an understanding of what is available within the Earth Engine catalog regarding to water and water bodies, water sources, etc., etc. Okay, so I think the next two is where we start getting interesting. This is where we start getting a little bit more, I think, towards the comment itself. So let's have a look at this specific data set. Okay, so we're going to go to Earth Engine, we're going to go to data sets, we will search for it, and there we go. Okay, so this is the one that I found very interesting. Remember, in one of the previous video tutorials, I actually spoke about this, where I said this is actually a very, very interesting data set, data set that I haven't used before. Sadly, I've only realized it fairly recently, but it's a very, very nice data set in terms of its time period. Problem is with the resolution. I mean, imagine if this one was 10 or 15 or 20 meter resolution or 30 meter resolution. But this is 11,132 meters. So it's a very, very low resolution. So that's the downer of this. But anyway, I assume you can't have everything all the time. Okay, so in here it's got a couple of things. It's volumetric soil water level 1, level 2, level 3, and level 4. Now what's interesting is this tells you the volume of water in the soil layer, 0 to 7 meters underground. The surface is 0 meters. So volumetric soil water associated with soil texture, soil depth, and interesting underlying groundwater level. So this is the first time we're now talking about underground water level. And this is exactly what we were looking for. Is this underground water level? So this is 0 to 7 centimeters underground. This is 7 to 28, which is layer 2, 7 to 28. Layer 3 is 28 to 100 centimeters. Level 4 is 100 to 300 centimeters. So this measures, I would assume, the volume of water within that different levels of soil underground, below surface. Okay, so level 1, level 2. So what I've done is I've just basically mapped level 1 or layer 1, meaning let's just move that there from 0 to 7, and then also for 4, which is 100 to 300 centimeters below. So that's underground, but it's fairly shallow. It's not like deep underground, like a kilometer, 2 kilometers underground. This is fairly shallow, up to 300 centimeters, which is what's it, half a meter, close to half a meter. But it says underground, so it is something to that effect. Whether that's what the person had in mind when he asked the question regarding the underground water, I don't know. But anyway, let's have a look and see what that looks like. So in this case, I select, there's my data set. I select my band. And then here is my filter date, which is basically the rainy season, the rainy period, the winter period in this particular area, which is 1st of April, 1st of July, and then we clip it. and then I reduce it by mean. Okay, so there's my data set. Selected the band, selected the time period, select my reducer, and clipped it for my region of interest. There's my visualization, parameters red, brown, and I display it. And as I said, I've done also one for the layer 4, which is the deepest we can go tend to. So let's have a look and see what that looks like. So that is layer 1. And you can see the size of the resolution, the size of the pixels, very, very low. Nonetheless, let's zoom out a little bit. So basically what it says here is, remember, and we're now with level 1. So it says there that red is closer to the minimum, blue is closer to the maximum. Yellow is closer to the minimum than to the maximum. So this is yellow, and then the green, and then we go into the bluish areas here. So this suggests that underground water levels, this side is much lower, or lower, let me not say much lower, is less than underground water levels on this side. And one would ask, but why would that be? And the simple reason is because this area receives much, much more rain than this area. This area is the drier side of this region of interest. It is much more sand. It's much, yeah, and this area is much more, the soil is much more clayey, so it holds water much more. It's more agriculture related. There's lots of more dams here, etc. And as I said, it receives much more rain. So that's most probably why it looks like that. So if we select, let's say we select this particular area here, so we'll say the soil, the level is 0.24 for layer 1, between 0 and 7.5 centimeters, 0.24, and then between 100 and 300 centimeters, 0.18. So that means volume fraction. Now, I'm not exactly sure what that means. Let's have a look and see. Units volume fraction. Now, again, one will have to have a go and have a look and see what does this mean. Volume fraction. Again, that's something that the person will have to just go and figure out. Let's have a look at that position there. 0.19, 0.15. You'll see there is no water there. You'll see that there's no water there. There's no water there. Okay, so that location there, which I used there, there is no standing water, there's no river, there's no water bodies, there's nothing. That's for certain. But it does have underground water, stored from rain, I presume. But what exactly that 0.19 and 0.15 means, I don't know. One will have to go and figure that one out. I think a Google search or go into this data set. The volumetric soil water associated with soil check, they said what its surface, it doesn't really say what it is, so we'll have to go and Google search this one. Volume fraction, I'm not sure what volume fraction means. Anyway, it shouldn't be too difficult to figure this one out, just a Google search should solve that problem. Okay, so that is for soil, so water, underground water within those layers, within that specific centimeters. Okay, so that's that. So not exactly my idea of underground water would be these sort of reservoirs or rivers or streams or dams of masses of water underneath the soil, deep below soil. Now, I don't know. I cannot see how satellites will be able to detect that. I really can't see that. So most probably there will have to be some modeling or something. As rain falls, it seeps into the soil, some evaporates. So you should be able to, if you understand the rain numbers, you understand the soil, you understand the evaporation rates, then in theory you should then be able to understand the underground water levels. And to a large degree, this is what the last one does, which is this one here. Now, to my mind, this is the one that I think talks, the data set that talks directly to the comment, or to I think what that person wanted. So if we go and search this, okay, if we go okay, so this is again from 2003 to 2024. So again, a image collection that is, in terms of time series, not too bad. The resolution is horrible. It's even worse than the previous one, which is 27,830 meters. So it's a horrible resolution, but beggars can't be choosers. Then if we go down, you'll see here, and this is also one that I didn't know about. So this is also an excellent data set, I have to admit. And this is the beauty of this channel, or the beauty of the comments. When the people submit comments, it forces me to go and have a look at these data sets, which otherwise I would never ever have a look at. And so it expands my horizon in terms of what is available significantly. So I have to say kudos and thank you very much. Anyway, this is a very nice data set, by the way, except for the resolution, which is not so bad, and it could have been a bit more in terms of the past. It's actually quite good. Okay, so have a look here. There's groundwater storage. It says snow evaporation, heat flux, sensible heat, net flux, latent. Again, not too sure what all these things mean, but here it sits. Groundwater storage in millimeters, so that makes sense. So this is the volume of water, I would assume, underground water, or these sort of dams or rivers or streams or whatever you want to call it and stuff. They don't say how, the distance below the surface, whatever that may be. But let's have a look. This boggled my mind. I didn't know this existed. So yes, let's go for it. In fact, it also snow, which I was looking, snow surface temperature, snow depth. Again, snow depth here. Again, something that didn't exist. Soil surface moisture. Brilliant. Anyway, so let's have a look here. Groundwater storage. Groundwater storage. So go into and there it sits. Okay, so it's an image collection. My ID, the dataset ID, the band that I'm going to select, GWS underscore T average. Sorry, where is it now again? There we go. There we go. GWS underscore T average. There we go. Let me just move it to where my script is. Filter, and I'm going to filter it for the same period as in the previous ones. You'll see that's the same period as for my underground layers. And then, sorry, and I clip it and I reduce it. Standard practice. Sorry, where is it now, man? Come on, there we go. There is the minimum and maximum values. Minimum and the maximum. I'm just putting these numbers here. One will have to play around with it. There's my color schemes, and then I add it to my maps or my layers. See what that looks like. You can see it's even worse. I mean, it's only 5 or 6 pixels that covers my whole area, but I would assume that's the nature of underground water, that these are fairly big, geographical areas, or areas under the surface. So yeah, and again, just interesting. This shows you the difference between the resolutions. You see, this is what did you say? 11,000 resolution. What was it? 11,000 meters resolution, and this is double. This is, well, triple, almost triple. And you can see this is the size of the pixel. And like, look here now, you can see the size of the pixel. It's almost triple. So it just shows you. And if we click on one of them, let's have a look and see. You'll see the storage is 410. And that would be now millimeters of water at that particular area. Let's go to the blue. That is 666. Let's go to the red. And that is, there's nothing there. Let's go there. 300. So it goes from about 300 millimeters around here to about 600 millimeters. And this correlates to the previous layers, which basically suggested that these have low underground waters levels, and these have high underground water levels. So it makes sense that the underground water storage would be higher in this side than in this side. So the two data sets sort of collaborate one another, sort of lend credibility to this idea that this side has much more water, underground water, than this side. And that, from knowing the area, makes absolute perfect sense. So there we go. And then basically I just put some charts together. So that is the chart on underground water based on level layer 4. You'll see we've done, on layer 4. And that's basically from the beginning of the data set to the most current period in the data set. Okay, so I select define my data range. I have my image collection and the band, and then I just generate the monthly number. So I basically just create the time series here if you want, where it starts with the beginning start date, and then you just add a month to that the whole time. So here you're basically creating the period, and then you just add the data to it for my region of interest, and then I just display the data set. Okay, I create the time chat. So this is what we're doing here. So we're creating the time series chart from this particular data set for layer 4. And that is it. And then we also create the data set or the time series chart for this one here, for this NASA data set, which is underground water. Same methodology. Obviously, I'm just changing the start date and date. I've just added one because you can't have duplicate star dates or different. If you have different star dates, you have to different variables. So so there it sits, and we create the chart, and there it's that one. That is how it looks. So you can see the underground. There was a significant decrease in underground water. Remember, this is now the median. It's the median. I've done median both for me. You'll see there's a median. Median reducer, again median. Now, why do I do mean there? Must be median. Median. And would I do the same here? Also median, should be median. Sorry. So that's the median. So you can see there's a significant decrease in underground water levels. Remember, this is the median for the whole region of interest, not for a particular location, but for the whole region. And you can see there's quite a significant decrease there. You can see that. But now it's on the increase. And you can see the high numbers or the high underground water is your winter periods. So again, there's logic behind it. It makes sense. And then your troughs here, your low points here is your summer, your heat, the end of summer. You'll see February, March, April, etc. There's something that happened here. Not sure what happened here because it's not presented in this as well. So whether these, okay, so it's a bit difficult to overlay them because this is only from 2003, where this is from 2050. So it's this whole period only actually covers this side here. You can see there it's that decrease there, which is that one there. That increase there was probably somewhere here. Okay, so yeah. But anyway, so there's the time series charts as well. So this is underground water within that level are between 100 and 300 centimeters, and this is just underground water in millimeters. And this is what they say volcanic soil water in cubic meters. So this is cubic meters, cubes. Okay, so that's already giving you some indication. Okay, so this is, yeah, so this is underground water. I hope this, and it would be, sorry, before I conclude, it would be nice to overlay this now with evaporation and participation to see how this sort of correlates. Because I said if the more rain, uh, in theory, the higher the underground storage. The less rain, vice versa. The higher the evaporation, the lower the storage, and vice versa. So in theory, this now assuming a constant or the soil texture is irrelevant, etc., etc. So that would be interesting to do those sort of calculations, is to generate similar ones for evaporation and participation, overlaid with this. Let's have a look and see. And that should all be yes. Now, there's evaptrans. I don't know exactly what this means. It doesn't have participation. But anyway, that we can get from other data sets and just overlay that. Anyway, something more interesting that we can do. Okay, so I hope that sort of speaks to that comment, the comment that talks about underwater or underground water. I'm not sure whether it addresses him or her, but let's see. Let's see. So, okay, point being is there's these data sets, okay, and they're fairly useful for different reasons or for different applications, whether it is flow, what is the flow direction of waters or body streams, or how often, what's the seasonality of these things, what is the depth of these things, whatever the case might be, is there's these data sets that can be used for whatever different applications related to water, surface water, and both underground water. Okay, cool. Yeah, thanks. It's was good. I think it was a good one. I hope you also found it interesting, just like what I found it. As I said, a couple of interesting things. I'm going to play around with this to see whether I can add this data set, this time format here as well, and see what happens. Because this is the first time I've actually worked with something like that. So there's a couple of new things that we've explored that we haven't explored together that may or may not be useful going forward or going back, depending on the data sets. Anyway, let me stop blubbering. Let's end it for now. Please, boys and girls, remember to smash those buttons, those subscribe buttons, those like buttons, and all those buttons. Just smash them and stay tuned. There's more on its way. We're going to address some more comments, and I'll see you on the other side.